In Part 1 and 2 of Full Stack Microservices Building series, we have learned how to quickly design, build and run full stack application with WeDAA Quick Start Wizard. In this video we will be exploring how to establish and exercise inter-process communication among microservices. WeDAA Canvas allows us to build and update existing architecture and enhance the application architecture. Logged-in user can access the previously built and saved application architecture from prototypes. Saved prototypes can be referenced and edited to enhance the application architecture and generated the code as and when needed. You must log into WeDAA platform to save your application architecture for future references. Application architecture saved can be accessed from Prototypes section of logged-in user account. All saved application architecture can be edited and enhanced on Canvas. To establish inter-process communication, we need to connect from and to services. For establish the connection on Canvas. WeDAA supports two types of inter-process communication among services, asynchronous and synchronous. With asynchronous communication, available message broker is RabbitMQ, and for synchronous communication WeDAA supports REST over HTTP. In this video we will be exercising synchronous communication among services using REST framework. Let's edit the full stack application architecture and add one more service to existing architecture. While adding new backend service, we will establish REST communication between backend 1 service to backend 3 service along with backend 1 service to backend 2 service. Let's establish the connection between newly added backend service and frontend React user interface. If required, we can add database as well for new service. Here we are skipping adding database as this video is about inter-process communication only. Let's add mandatory required attributes for newly added service in our full stack application architecture. Component name, package name, and server port are mandatory fields of springboot backend service. Port number used must be unique across the components. If the port is already assigned for some other service, we will get error message. Let's validate the updated application architecture and generate the code. Let's unzip and add the project to an editor of choice. Architecture components communication and configurations can be validated with apps-blueprints.jdl file generated in the Blueprints folder of application. Web app will be accessible on 4200 port. Backend 1 on port 8081. Backend 2 on port 8082. Backend 3 on port 8083. We can verify the communications established among various components of application as well in communication section of apps-blueprints.jdl file. To exercise the communication among application services, you can look at the communication.md file in the services root directory. Here, inter-service communication is set up as synchronous between services. In the communication.md file, there's a section about communication among application components. It shows that the communication is set up between backend 1 and backend 2. In this setup, backend 1 acts like a client, and backend 2 acts like a server. We need to start the service before exercising the inter-process communication among services. Please refer Part 2 video of Microservices series of full stack application building. Let's build the curl URL to test the communication between services. As per the communication port of client needs to be updated in given URL. On the execution of curl command, we see the response from backend 2 server, whereas the request was originated from backend 1 server running on port 8081. Same goes with backend 3 server. While the request was originated from backend 1 server and response is received from backend 3 server. The code responsible for communication between services is located in the communication directory within the web folder of the specific backend service code. The properties variables are set for communication are located in the application YAML file of the service in for the specific environment. As per the communication properties setup, we can see backend 1 service is having communication with backend 2 and backend 3 service. Let's update the response received from server 3 and see call the service once again from backend 1 client. We will be updating response in server resource.java file of backend 3 service. Once updated, service need to be built and started again. Here we can see the response received from backend 3 is updated with the latest response. Let's verify the same with server logs as well.